welcome back to our discussion about the natural exponential function. In part 1 of the video, we discussed the derivative of the natural exponential function. In other words, the derivative of the e to the x is awesome. It's just e to the x. And then if you have something other than x in the exponent, then you'll have to use the chain rule. Well, if the derivative of e to the x is e to the x, well, so is the integral, right? So the integral of e to the x dx is e to the x plus c. Remember, an integral is always a family of functions. This is called the general solution. Now, what if you have something other than x up here? Then you can attempt a u substitution. So if you could rewrite your integral in the form of e to the u du, then your antiderivative or your integral is e to the u, and then plus c gives you, again, the general solution or the family of solutions. Okay, so let's try some problems. All right, so calculate the integral e to the 2x dx. Now, of course, I could give you just e to the x. So let's say our first problem is the integral of e to the x dx. Well, there's nothing to do, right? It's just e to the x plus c is actually property 1 right there. So I'm going to have to always give you something a little more interesting than that. Now, for the first one, you want to let u, if you have an e to the x, so we have u is equal to 2x, and then du is equal to 2 dx. So remember, whenever you let u be something, and again, a good idea if you have an exponential function, or base e in this situation, is to let u be the exponent. And then you have to find du. So remember, the derivative of u is 2. Really, the dx was under here, and we always multiply both sides to get it over there. Now, when you look at your problem, when you rewrite with a u substitution, you have the integral of, this is going to be e to the u. Okay? Now, everything else outside of this e to the 2x, which is e to the u, must be your du. Notice our du has a 2 dx. We don't have a 2 dx. Can we fix that? Sure we can. I can put a 2 in there with that dx as long as I adjust it by putting a 1/2 out front. So when we go back down here, I need a 1/2, and then again, I have du, because du is this part right here. So remember doing that? Okay. Now, I keep going. So I have 1/2. Now the integral of e to the u du, we know is e to the u plus c. Then I have to substitute u back in. So this is 1/2 e to the 2x plus c. And there is my integral. Remember, it's an indefinite integral of e to the 2x. All right, so let's try another one. Okay, so again, here, notice it looks a lot more complicated. It's really not. The integral of e to the negative x to the 4th times negative 4x squared dx. So again, the attempt is to try to let u equal the exponent, and then just see if you can't get du out of that. So let's let u equal negative x to the 4th. The derivative of that, du, is going to be negative 4x to the 3rd dx. Remember, I'm using the power rule. Okay. Now, I've got an issue, and I'll be honest with you. I think what's going on here is this is a typo. Okay. I'm not trying to multiply by x or anything. That should have been an x to the 3rd right there. I'm not trying to do a complicated problem right now. So this is negative 4x to the 3rd dx. Notice that's exactly what we have. And again, forgive me for the typo. That's negative 4x to the 3rd dx. So this is the integral of e to the u, whereas highlighted here in the blue, that is my du. Okay, so this is the antiderivative of that is e to the u plus c. I didn't even have to fix anything. We had exactly what we needed right there, at least when I fixed the typo. And that's going to be e to the negative x to the 4th plus c. And there we go. So let's continue with our examples. Now this looks a little different. I have the integral of e to the 2x over 1 plus e to the 2x dx. Now the question is, what do you let u be? Now before, I said a good thing is to let u be the exponent when you have a base e, right? So if I let u be 2x, That's certainly not going to pick up, like, I could let it be this 2x, and the derivative of that is 2dx. That's not going to pick up all the rest. Or if I let it be this 2x, that's not going to pick up all that. Okay, so I don't want to tell you 100% of the time let u be the exponent. That's always a good attempt when you have a simpler problem. Another guideline for to let the u be is to let u be the denominator. Okay, and you've done that in other problems. Let's try that here and see if it works. So if I let u be 1 plus e to the 2x, okay, what is the derivative of that? So the derivative of 1 we know is 0. The derivative of the e to the 2x is e to the 2x times 2 dx, right? Use the chain rule. That's what we did in the last video. If I rewrite that where it looks a little better, that would be 2e to the 2x dx. Now let's think about what that means. All of this was u, right? And du, I'm going to highlight it in, let's go back to the aqua right here. But what am I missing? I'm missing a 2, right? We have the e to the 2x dx right here, but it's missing a 2. Can I fix that? Sure, if you're only missing a constant, you can certainly fix it. So what I'm going to do is I'm going to multiply inside by 2 and outside by 1/2. Right? Now I have my du, so I have 1/2, the integral. On the top, all of that is du, and in the denominator, that's u. If you'd rather think about that as 1/2 the integral of 1 over u du, you go right ahead. I tend to think about it that way. We know whenever we have 1 over u du and we're integrating, that is a natural log. So this is 1/2 the natural log of the absolute value of u plus c. Remember a couple of sections ago that I plug u back in, so that's 1/2 the natural log. Remember u way back over here, 1 plus e to the 2x plus c. And there's your antiderivative, or your indefinite integral. Remember the same thing. Alright, check out k. We've got the definite integral this time of 0 is your lower limit to square root of 2 is your upper limit of x times e to the negative x squared over 2 dx. So we're finding the area this time, right? The area from this curve down to the x-axis between x equals 0 and x is equal to the square root of 2. I say pause it, see what you can do with this thing, and then come back. Hint, let the u value be the exponent. I think that'll get you what you need. Hopefully it went well for you. So again, let's go with that hint. Let u equal negative x squared over 2. So the derivative of that, du, now look, if you need to think about that as just negative 1/2 x squared, y'all, that's all that's really going on, right? So the derivative of that is going to be negative 1/2. I'm using the power rule, so times 2x to the first, and then dx, which is du is equal to, the 2's cancel, just negative x dx. Well look, we have an x dx right here. There's an x dx. All this part right here is e to the u. I don't have the negative. Can I fix that? Absolutely. Let's throw in a negative in front. So there's my negative in front and my negative 1 outside to compensate. So now I have negative. Okay. And then this is the integral. Now, I know I have limits here, but since I'm writing this in terms of u values, they're not 0 to the square root of 2 anymore. So I'm just going to leave them off for the moment. This is going to be e to the u du. Do you see that? Again, the du is the negative x dx that I have underlined on the outside, and the e to the u is the squared off part. Now we're finding the antiderivative of this. Don't forget that important part. The antiderivative of e to the u du is just e to the u du. So I have the negative still in front, e to the u. But now I'd put plus c, but I'm not, because I have limits of integration. Now again, because I have a u here, I can't write 0 to the square root of 2. I could plug 0 and square root of 2 into my u, or I could go back and plug u back into my function and make it in terms of x. So it'd be negative e, and then remember u is negative 1/2 x squared, or negative out front x squared over 2, okay? And now that's evaluated from 0 to the square root of 2. I can put them there because I'm in terms of x again. So I'm not going to plug in the square root of 2, so it's negative e, negative 1/2, the square root of 2 squared, minus, now I'm going to plug in 0. So minus, and again, that's negative e, negative 1/2, 0 squared. Follow all that? All right, now up here, square root of 2 squared we know is 2. So this is negative e to the negative 1/2 times 2. Now this minus and this minus turn into a plus e to the negative 1/2 times 0. Doing this in extreme detail. Notice these 2's cancel. So negative e to the negative 1. Okay, and then this is 0 plus e to the 0, and we know anything to the 0 except 0 to the 0 is 1. So that is your exact answer for this area between 0, square root of 2, the curve, and the x-axis. One more note I should point out, this e to the negative 1, you could write it as this. I didn't want to throw you off if you saw the answer and it looked like that instead of the above. You know, the e to the negative 1 you could take to the denominator and make it e to the first. So this actually to me looks a little bit better, but they're both accurate. Alright, next problem. What in the world am I going to do with this? You know, so some advice I've thrown out there to you is let u be the exponent when you have a base e. Well, I've got 3 of them, right? I've got a 2x as an exponent, I've got an x as an exponent, and down here I have an x as an exponent. So if I let u be the more complicated, like 2x, then du is 2. That certainly doesn't pick up the rest of this stuff, right? Same thing if I let u be x. Another piece of advice is to let u be the denominator, e to the x. Well, the derivative of e to the x is e to the x, and that's not going to pick up all these terms that I have up top. Here's my advice in this case. Let's split this up and simplify. So I'm going to write this as e to the 2x over e to the x plus 2e to the x over e to the x plus 1 over e to the x dx. So you see what I did? I just put the e to the x underneath each term. Now I'm going to simplify that. So this is the integral. Now e to the 2x over e to the x. Remember what you do with those exponents? When you divide bases, you subtract. So 2x minus 1x is just going to give me e to the x for my first term. Now here, this e to the x and this e to the x cancel, so plus 2 is my second term. And then this 1 over e to the x, we dealt with that in the last problem, it can be written as an e to the negative x. Now, we can find the antiderivative of this without even using u substitutions. Actually, you would need a u substitution on the last one. So I'm going to do the integral of e to the x dx plus the integral of 2 dx plus the integral of e to the negative x dx. Now, usually I don't split it up as 3 separate integrals, right? Like when we deal with a polynomial, we just jump in there and do it. But since this last integral requires a u substitution and these two don't, I decided to go ahead and write it separately instead of just doing that in my head. The integral of e to the x dx is e to the x. Okay. The integral of 2 dx, remember, the integral of a constant, you have to put the variable in there, so it's going to be 2x. Now here, I'm letting u equal negative x. Du is negative 1 dx. I don't have a negative 1, right? So I need to put a negative 1 in here with my dx and a negative 1 in front to compensate. So this is going to give me minus the integral of e to the u du. Now we know that that integral is e to the x. I'm recopying the first 2 integrals. That would be minus e to the u plus c. Now notice this is x's and this is u, so really I got a mixed up problem over here. But I'm going to go back and plug my u back in. And remember, u is back up here as negative x, and then finally plus c. And that is my indefinite integral for the original problem L. Again, I should throw in that quick note that this term could be written as negative 1 over e to the x also. Okay, so you'd probably see it written like that if you were to look the answer up in the back of the book. Okay, it's trick time, right? It's trick time, it's trick time. Now, what should we let u be? Remember, the going rate originally is to let u be the exponent if you have an e to the x. Then sometimes we let u be the denominator, sometimes we have to be more creative. But start with the most basic thought first. So if I were to let u equal tangent of 2x, would that work out for us? Well, to find out you need to take the derivative. So du, now remember the derivative of tangent of 2x, you may have to go back and look this up, but the derivative of tangent is secant squared. Now this requires the chain rule, so derivative of tangent would be secant squared of 2x times the derivative of the inside, so times 2, and then you need that dx, right? Now look, that's almost what we have. There's my secant squared of 2x dx without the 2. Is that a problem? Certainly not. We can put a 2 inside with it if we put a 1/2 in front to compensate. So what does that mean I have now? Well, I have a 1/2, and I have the integral. This first part right here, that's e to the u, and then all this that I have rectangled off, including the 2, right, is du. And then the antiderivative of e to the u du is awesome. It's just e to the u, right? So that's 1/2 e to the u, because this is an indefinite integral, I put the plus c. I go back and plug my u back in. That's 1/2 e to the u is tangent of 2x and then plus c. And that's my final answer. Now here's another fun one for you. So example n, the integral, notice again an indefinite integral, of the natural log of e to the 2x minus 1 dx. Now the question is, what do we do here? If you let u equal the exponent, 2x minus 1, and we take the derivative of that, are we going to pick up the information on the outside? And listen, we're not, right? As a matter of fact, we don't even have a rule for finding the antiderivative of a natural log right now. We don't have that rule. We know the antiderivative of 1 over x is natural log, but we don't have a formula for the integral of a natural log right now. But let's think about what we have inside here, and can we even simplify this? Maybe. Aren't natural log and e inverses of each other? So do they not just cancel out, this natural log and this e? So this is essentially the integral of 2x minus 1 dx, because the natural log and the e are inverses. And we know how to do that, right? The integral of 2x, okay, bring the 2 down, use the power rule, x squared over 2, minus the integral of 1 is x, and then plus c. So x squared minus x plus c. So actually what looked really complicated could be simplified first before we found the antiderivative. And this is the last problem I have for you. Notice this is a differential equation, and to solve a differential equation, remember the first step was we multiply both sides by dx. So we have dy is equal to e to the x minus e to the negative x all squared dx. Now to get rid of the dy, we do the opposite operation, which is going to be, remember that's the derivative, so we find the integral. So the integral of dy is the integral of e to the x minus e to the negative x all squared dx. And the integral of dy we know is y, but then we've got to focus on what are we going to do on this side. This is where all the work comes in on the right. Now, if I were to let u be an exponent, that's certainly not going to pick up the stuff on the outside, right? If I were to let u be the inside, often that's what you do, right? It'd be e to the x minus e to the negative x. If I take the derivative of that, that's certainly not going to pick up this dx on the outside. We're going to have all kinds of extra stuff. So y'all, what we really need to do here is expand this. This is the integral of e to the x minus e to the negative x times another e to the x minus e to the negative x dx. Right? Now we could, I was just going to multiply all this out, but now that I think about it, if we let u be this, e to the x minus e to the negative x, then du is going to be e to the x minus e to the negative x. That's interesting. So let's try that. Okay, so I'm going to let u equal e to the x minus e to the negative x dx. Actually, no, we haven't taken the derivative yet. Du. What's the derivative of e to the x? Well, it's e to the x, right? What's the derivative of minus e to the negative x? This doesn't work, right? Because when I do the derivative of e to the negative x, it's going to be negative e to the negative x times negative 1, which is going to make that a plus, which is not going to give us the other one. Okay, so this doesn't work. I got to go back to my original method, which is going to be to multiply all this out, which was really my original plan. I just saw that last minute and thought, let's try it, but I've got a sign issue, so use substitution doesn't work. So when I multiply this out, I have y equals the integral. So e to the x times e to the x is e to the 2x, right? When you multiply bases, you add exponents. E to the x times negative e to the negative x is going to be negative e to the 0, because I add x plus negative x is 0. Then negative e to the negative x times e to the x is going to be negative e to the 0 again, because I'm adding these exponents. And then negative e to the negative x times negative e to the negative x is going to be plus e to the negative 2x. Again, I'm adding these exponents together. dx still at the end. Let's simplify a little bit before we find the antiderivative. So it's going to give me e to the 2x. Now this is 1 and this is 1, so minus 2 plus e to the negative 2x dx. Now what's going on? Kind of like the last problem we did, I'm going to split this up into 3 separate integrals. So I have the integral of e to the 2x dx minus the integral of 2 dx plus the integral of e to the negative 2x dx. Now for this first one, I'm going to let u equal 2x, du is equal to 2 dx. I don't have a 2 dx, so I'll put a 2 here and a 1/2 out front. This one is not going to be middle term. It's not going to be any trouble. It's just going to be 2x when I find the antiderivative. But on this one, I let u equal negative 2x. du is negative 2 dx. I don't have a negative 2, so I'll put a negative 2 here and a negative 1/2 out front. Okay? That was confusing. Make sure you go back to your others and look at us doing those basic u substitutions with e. Okay? Now, let's keep going. When I find this is going to be e to the u, right? And then we'll plug u back in, and there's, don't forget that 1/2 out front, minus, this is just going to be 2x. This is going to be minus 1/2 because of the negative 1/2 out front, and this is e to the u. So my final answer is y equals 1/2. I'm plugging the u's back in for their respective integrals. So this is going to be e to the 2x minus 2x minus 1/2 e to the negative 2x, finally plus c, and I should have put a plus c there. Do we have any like terms? No, we don't, because this is e to the positive 2x, this is e to the negative 2x. We cannot combine those together. I know they got a little squished at the end. Make sure you pause it, work through those ideas yourself, those separate integrals, and please let me know if you have any questions. I hope you have a wonderful day.